Hi everyone, welcome to Fundamentals of College of Mathematics, HPU's Math 1101. My name is Summer Slater. I'm going to be your instructor this term. I'm so sorry about missing this first class. Hopefully this will help to get you sort of set up with a lot of the basics of Math 1101. We're going to go ahead and start our lecture. You'll have 4 different videos, one for each section that we'll be doing. We'll be going over some examples together, talking about vocabulary, as well as having some try-it problems for you to pause the video, try it, and then you can go ahead and see how you did, and then we'll work through those try-it problems together. So let's go ahead and start. So we're going to just start with section 1.1, talking about numbers, variables, and expressions. And the very first thing that we need to know is we need to know about natural numbers. You know what? Let's go ahead and just cover that up for now. So the first thing we need to know is we need to know about natural numbers. And natural numbers are also known as counting numbers. And so when you think about that, well, counting numbers, what does that mean? Well, what number do you start counting with? You start counting with 1. So 1 is an example of a counting number, and then when you count, what's the next logical number? 2, 3, 4, and so on and so forth. Right? You continue to go on. We use our ... just to show that it's a never-ending sequence. After natural numbers, we have these things called whole numbers. And whole numbers are all of your natural numbers and the number 0, kind of like a whole, right? 0. So we have 0, 1, 2, 3, and so on and so forth as part of our whole number family. Now, when we're talking about natural numbers and whole numbers, we want to deal with factors, these things called factors. And factors are just numbers. Now, most of the time, we consider factors to be natural numbers or whole numbers that are multiplied together to make a product. So, product, just as a reminder, deals with multiplication. And so, for instance, if we're taking a small number, like let's say 6, factors of 6 are 1 and 6, because 1 times 6 equals 6, and then also 2 and 3, because 2 times 3 also equals 6. So you actually have 4 factors here: 1, 2, 3, and 6. So now that we've talked about factors, we're really going to be dealing with this when we're looking at prime numbers and composite numbers. Whoops. So prime numbers are natural numbers, so remember 1 up. So natural numbers greater than 1 that are only divisible by itself and 1. Your textbook has a little more complicated definition for it, but that's pretty much the gist of it. Natural numbers that are greater than 1 and divisible by only itself and 1. So what's your first prime number? It's actually kind of different, because you think of prime numbers as being odd numbers a lot of times, but your first prime number is actually the value 2, because 2 is a natural number that's greater than 1, and since it's such a small number, it's only divisible by 2 and 1. So 2. Now 2 happens to also be your only even prime number as well. So after 2, then you have 3. 4 is your next number, but that's divisible by 2, so that's out. 5 is your next prime number. 6 is divisible by both 2 and 3, so those are out. 7, 9, 8 is out, 9 is out, 10 is out, 11, 12 is out, 13, 14 is out, 15 is divisible, 16 is out, 17 is only divisible by itself and 1, 18 is out, 19, and you kind of get the gist here. And really the only way to check if you're unsure is to just, grab a calculator and say 351 divided by 3, 351 divided by 7, 300, and try those values out. Okay? Now, if a number is not prime, then it is composite. So composite numbers are, again, natural numbers greater than 1 that are not prime. Simple as that. It's basically the opposite. So your first composite number, if we take a look back at these numbers here, again, greater than 1. So the first composite number is 4. And then a lot of your every even number after that, right? 6, 8, 9, 10, and so on and so forth. Okay, now when you're looking at composite numbers, you can actually express composite numbers as a product of prime numbers, which is called prime factorization. Prime factorization is a way to organize numbers. It's a tree, or like a factor tree or a number tree, that's used to write the factors of a composite number as a product of prime numbers. So for instance, let's take the value, I don't know, let's think of a large value, 120. Okay, what I'm going to do is I'm going to first break it up and say, okay, what are factors of 120? And I want to think of my smallest prime number that I can divide out of that first. And I automatically see it ends in a 0, so I can divide it by 2. So I think 2 and 60. And because I can't break up 2 any further to be useful, I'm just going to circle it to show, hey, that's my prime number, we're good. And then I'm going to break up 60 in the same manner. So I know I can divide that also by 2 and 30. And then 30 we can break up into 2 and 15. And then 15, lastly, we can break up into 3 and 5. So 120 is a composite number, and it can be expressed as 2 times 2 times 2 times 3 times 5. Or later on when we learn about exponents, we could express it as 2 cubed times 3 times 5. But this is perfectly fine for doing an example like that. We do normally start with the smaller numbers and then go to larger numbers as needed. So I can turn this page here. Let's go ahead and do our first example. Now, all of these examples that you see on here can be found under your syllabus and course materials. This is under the notes, section 1.1 to 1.4, so you can go ahead and print those out if you want. Normally, I will be handing them out in class, so you'll have it. You can print these out though if you like. So for example 1, it asks you to classify each natural number as prime or composite if possible. If a number is composite, write it as a product of prime numbers. So we go ahead and take a look at 31. We say, okay, 31. Can we divide it by 2? Obviously not, because it's not an even number. Can we divide it by 3? No. 4, and again, it just becomes trying more and more numbers. Now, when we grab our calculator and we try this, we're going to realize, hey, we can't divide it by anything. So I'm just going to go ahead and say that is prime. Nice and simple. Okay, next we have 135. I automatically see the 5 at the end, so I know it's divisible by 5, so I'm not even going to try to check it on my calculator, right? If you can do something like that, then go for it. So I know that this is automatically composite. And now I want to write it as a product of prime numbers. So I want to do a prime factorization. So we have 135. We know that we can automatically divide it by 5. We break it up into 5 times, I think that's 27. We break up 27 into 3 times 9. And then lastly, we can break 9 up into 3 times 3. I'm running out of room there. So our number 135 is composite, and it can be written as 3 times 3 times 3 times 5. And that would be our answer right there. The last one is 1. So we look at 1 and we say, well, it's 1, right? Well, let's just really quickly take a look back at our vocabulary words, right? Prime numbers and composite numbers. If you look at both of these are greater than 1, right? The numbers have to be greater than 1 in order for it to be prime or composite. So, oops. 1 is not greater than 1. So this one's kind of a trick question. It's actually neither. It's neither prime nor composite. Okay, so that's done with our first example. So moving on. Now, a really important part of algebra is variables. Variables, one of the most important parts about algebra, because algebra is all about an unknown quantity, something that you don't know. You don't know everything, right? So that's what a variable is. It's a symbol, typically a letter, that's used to represent an unknown quantity. Now, a lot of times when we're looking at variables, the most common variable that we use is x. We see x a lot, we see y a lot. N, I remember back in school, N would be used a lot for N for a number, right? But you're really not limited to any of those. You can use any letter in the alphabet. So A, B, blah, 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 blah. Whatever else you want to use there. Now, along with variables comes algebraic expressions. And an algebraic expression consists of numbers, variables, operation symbols, and grouping symbols. So numbers, that's self-explanatory, right? Counting numbers, whole numbers, all of those numbers. Variables, we just discussed that up here. Letters to represent an unknown quantity. What in the world are operation symbols? Well, operation symbols are your operations, like order of operations, so addition, subtraction, multiplication, which we typically use a dot for, and then also division. So those are your operation symbols. And then lastly, we have grouping symbols. Now, grouping symbols, they can be parentheses, they can be brackets, or they can be these things, these squiggly things called braces. So that's what an algebraic expression is. So an example of an algebraic expression could be a number, 5, right? It could be a variable, A, B. Ooh, a variable put together. Could also be operation symbols or grouping symbols. So let's see here. Maybe we have 5 plus AB. That'll work, right? We actually have operation symbols in between here when two letters are next to each other, or if we have something like 5A, that automatically implies multiplication. After expressions, we need to learn about equations, which is a mathematical statement that two algebraic expressions are equal. So, for instance, an example of an expression using something up here is 5 plus AB equals 5A. Now that's something that you're going to learn how to solve in Math 11.01. In Math 11.01. But for now, that's a good example of an equation. Mainly, an equation has an equal sign. That's the most important part about an equation. And an expression does not have an equal sign. So our first example here asks us to evaluate each algebraic expression for y equals 2 and z equals 8. So our first one, 3yz, again, that means 3 times y times z. And all we're going to do is we're going to substitute. Wherever we see y, we're going to substitute in a 2. Wherever we see z, we're going to substitute in an 8. And typically when you're substituting a value in, you want to put a parenthesis around there, sort of just to show that you are substituting the value in. So it would look something like this. 3 times 2 times 8. And then we would go ahead and multiply that together. 3 times 2 is 6. 6 times 8 is 48. Next, part B, we have z over y. So again, we're going to substitute those values in. So we have z as 8 over y, which is 2, which is just 8 divided by 2, or 8 over 2. And that gives us a value of 4. Nice and easy. What's next? Okay, so now that we've talked about expressions and equations, we want to look at formulas. And a formula is basically a special type of equation because it has to have an equal sign, but it expresses a relationship between two or more quantities. So, for instance, when you're talking about converting yards into feet, right, we could say, let's see, uh, we'll use F to represent feet and Y to represent yards. We would say F, or feet, equals 3Y, right? 3 times the number of yards. So, example of a formula. Let's go ahead and evaluate these formulas. Now, we don't always know the relationship that we have, but sometimes we're just told, oh, this is the relationship. Like, for instance, here, example 3. Find the value for Y when X equals 15 and Z equals 10. So we go ahead, and again, we substitute, and when we substitute, we always put it in with parentheses. It's a good habit to get into for later. So we have Y equals 15 minus 3. Well, 15 minus 3 is 12, so Y equals 12. Now, how would we check that? We could actually check that by taking the Y value and plugging everything in and just checking to make sure that both sides equal up, right? So we could say, okay, 12 equals 15 minus 3. 12 equals 12, and hey, yep, 12 does equal 12, so it works, and we're happy it works. So let's go ahead and do our other formula, Y equals Z over 5. Again, we're going to substitute in 10 for Z, so Y equals 10 over 5, and Y equals 2. Again, we can go ahead and check this. We have 2 equals 10 over 5, and does 2 really equal 2? Yes, it does. So again, we're happy. So we've talked about different types of numbers. We've talked about expressions and variables and formulas. Now we're going to go ahead and discuss symbols and their associated words, because, you know, in algebra, when we're talking about variables and unknown values, we also need to know, okay, well, what words mean what symbol, what operation symbol? So our first operation symbol is going to be that symbol right there. So what words tell you to do this? Well, addition, right? This is an addition symbol, so addition. Now, coming with that, we have add. We could also say plus. Another word that's kind of like the answer to an addition problem is sum. And a lot of times when you go to the grocery store, right, you have a total. This is your total. Okay, next, we have that sign right there, so that's going to be subtraction. Along with subtraction, we have minus. We could also use the word less. We want to remember the answer to a subtraction problem is called a difference. That's pretty good for now. We'll go ahead and stick with that. Next, the dot. What does the dot mean? The dot means multiplication. Along with multiplication, we could just say, hey, multiply, right? Multiply these numbers together. We could specifically say twice or double. The answer to a multiplication problem is product. Oops. And then our last symbol that we have is this symbol right here. So what's that? That is a division sign, or just division. It implies division, which is the same thing as divide. Oops. Oh boy. Or divided by. The answer to a division problem is called a, starts with Q, quotient. So all of these words, will imply these individual symbols, right? Addition, add plus sum total. Oh, you know what? We could also add in more. That works. So let's go ahead and try an example here. It says translate each phrase to an algebraic expression, and then it says define all variables used. So of course we want to define it because we need to know what the variable is standing for. Now I don't like to just be basic here. I like to give some good variables. Don't always use x. So twice the cost of a CD. So what are we looking for? What is the value that is unknown? The cost of the CD. So that's going to be our variable. And what do we want to say? I like C for cost. So C equals the cost of a CD. Don't just say a CD because it's like, well, what? The number of CDs you have? How long you've had a CD? What is that? Right? The cost of a CD. So we say twice the cost of a CD. What does that imply? That implies twice multiplication. So we could write it a couple different ways, right? The old school way from like back in elementary school days, that would be 2 times C. But you notice the times sign there kind of looks like an x, a variable. So we could make an asterisk there, or we could just say 2 times with a dot C, or we could just say 2C. I'm just going to go with that one since that's right underneath my little answer there. Okay, next, part B, 10 less than the president's age. So what's the unknown? The unknown here is the president's age. So I like P for president. P equals the president's age. So 10 less than the president's age. Now, these less than, they always kind of trip people up. People want to put, oh, 10 less than, so 10 minus P. But if you're looking at that, if you say, hey, the president is 50 years old, right? What's 10 less than 50 years old? 40 years old. So how did you get that answer? You took 50 and you subtracted 10. So that's what we're going to do. We're going to take P, our president's age, and we're going to subtract 10. Okay? Part C, a number plus 10, all divided by a different number. So what are our unknown values here? We actually have 2 unknown values. We have a number and we have a different number, which is kind of funny, but you know that's what we're going to use. So we have, I'll be traditional, I'll say n is a number. And then what should we use for that one? D maybe? D is a different number. I'm going to be lazy and use the number sign. So how do we represent that? It says a number plus 10, all of that divided by a different number. So a number plus 10, well, plus implies addition. So a number plus 10. Now, when we say all divided by, you could either say all of this by putting it in grouping symbols, divided by a different number D, or another way to express a division problem is representing it as a fraction. A number plus 10 all divided by D. So you actually have a bunch of different ways to represent that one there. And then finally, part D, the sum of the heights of 2 children. Okay, so what's our unknown? Well, we have 2 children and it's their heights. So we're going to have 2 different variables here. I'm going to maybe use S and T. So I'm going to say S represents the height of one child and T represents the height of the other child. Height of a child and T is the height of the other child. So we say the sum, right? The sum of their heights. Sum represents addition. So we say S plus T. Now notice the T could look like a plus sign, but I put my little hook on there to show, hey, that's a T. So maybe if you could do that too, especially when you were having a quiz in class, I don't want to have to ask you, hey, what is this? Let's just go ahead and make sure that it's very distinct that it's a variable. Now, I'm using a lot of lowercase variables here. You can use uppercase variables. So like I used a sort of, kind of looks like a capital P. You can use that. Okay, so our final example, example 5, talks more about formulas. It says the area A of a rectangle equals its length, L, times its width, W, as illustrated in the figure to the right. So here's your rectangle. Here's the width, and here's the length. And it really doesn't matter which one is L and which one is W. You could switch those around. But mainly here it's just asking you to write a formula that shows the relationship between all three quantities, A, L, and W. Well, we want to read that statement again. It says the area A of a rectangle equals. So it's saying A equals. That's kind of easy. Its length times its width. And times is another one of those words that we learned about, right? Times. Ooh, did we not put that in there? Oh, I didn't put that in there. Let's go ahead and add that in. Times is also multiplication. So the area of a rectangle equals its length times its width, L times W. And then it asks you to find the area of a standard sheet of paper. So we're told that the width is 8.5 inches, W equals 8.5 inches, and L equals 11 inches. So we go ahead, A equals 11 times 8.5. Oops, I forgot our units, inches, and inches. We go ahead and multiply those together. Sorry, I gotta go grab a calculator really quick. No calculator. Okay, I guess I'm gonna do this math longhand then. 8.5 times 11, that's 5, that's 8, space, 5 and 8, 5, 13, and 9, and 1 decimal. Okay, so the area is 93.5. Now, if we look back, we have inches times inches. We haven't learned about exponents yet, but we can sort of precursor this. A lot of you know that an area is normally a unit squared, and that's exactly what this is. It's inches squared. So that is your area. That is your formula for area. So that concludes all of our examples. Here we have some try it problems for you to go, oh, hey, not the answers. We have some try it problems for you to look at. You can go ahead and pause the video. Go ahead and try some of those problems. See which ones maybe you had a difficult time on, and maybe try those. It's really up to you which ones you want to try. Go ahead and pause the video, and in a quick second, we'll go ahead and go through those answers and the reasons for them. Okay. Oh. Whoops. Okay, so let's go ahead and do these answers. So, classify each natural number as prime or composite if possible. If a number is composite, write it as a product of prime numbers. So here we have the value 19. We want to take a look at this, and we'd go ahead and check in our calculator, is this divisible by 3, by 7, by 9, and so on and so forth, and just double check. For us, we know that it is prime. So prime, and that's it. Next, 205. So we have 205. I automatically see it is going to be divisible by 5, so I know it is composite. And we'll do our prime factorization for 205. We can divide it by 5. That would be 41. And then 41. Is that divisible by anything? Let's check. Nope. So that's a prime number. So it's only 5 times 41. That's pretty large, but that's okay. Next. Numbers 3, 4, and 5. It says evaluate each algebraic expression for x equals 4, y equals 2, and z equals 8. Again, when we're substituting these values in, we want to put parentheses around it, at least for the first step, just to show that we are substituting. So we have 4 plus 8 over 2 minus 2. We simplify that, right? 4 plus 8 is 12, and 2 minus 2 is 0. Now if we plug that into our calculator is going to give us an error message. And the reason it's going to give us an error message is because this is division, right? 12 divided by 0, and mathematically we're not able to divide by 0. If anybody has a question on why can't we divide by 0, I'd be more than happy to explain that to you in class next week. Okay, so for right now, we call this undefined. Okay, number 4, we're substituting 4 times 2 plus 8. 4 times 2 is 8. 8 plus 8 is 16. And that's our simplified algebraic expression. Okay, next, find the value for y. Find the value of y for x equals 15 and z equals 10. So again, we'll just go ahead and substitute the values in. Y equals 8 times 15 times 10. Now we haven't learned about order of operations yet, but when we're dealing with multiplication, we can actually start anywhere we want. You can multiply the 8 times the 10 and then multiply that by 15, or the 8 times 15 then by 10. I'm just going to do the 8 times 15 and then by 10. So we have 8 times 15, which is 120. We're multiplying that by 10, which is 1200. And then finally, our last translating, I'll leave that down there. Our last translating, define all variables. 4 less than a number. So again, we want to define our variable. Again, we have that number. So we could say, let's see, we haven't used k. So we'll say k is a number. 4 less than a number. And we talked about this less than phrase, right? We talked about it when we were dealing with the president's age. Remember, this less than sort of tells you, hey, go in reverse. So k minus 4. And then lastly, the product of 6 and a number. So again, we have a number. I use m, is a number. What does product imply? Product implies multiplication. So 6m is a simplified answer. Okay, so that concludes our first section for 1-1. I know it's kind of wordy, but I'm just trying to be really thorough. You aren't really able to ask questions right now. Go ahead and go through the homework. You can access it through Campus Pipeline. You can go to Blackboard Learn, and then from there, on your course content page, you'll have an access to My Math Lab homework. Click on that. All of your homework is in one session. Now you can do every single problem as many times as you want. It's up to you until, to get the grade that you want. These homework assignments that for the lessons that we're doing today, 1-1 through 1-4, are all due by next week's class, so by 5:30. If the computer cuts you off, that means you are late to class. So I'll say goodbye for now, and you can go on to the next video when you're ready.